All right, so we're still looking at area. Just as a reminder, what we saw yesterday. Yesterday, we saw area of shapes, right? We started looking at rectangles, parallelograms, triangles, trapezoids. We saw regular polygons, and we saw kites and rhombus, right? We saw those, and I'm hoping you guys are like, oh yeah, those were not bad. Now we're gonna be starting moving into combining shapes. Make sure the work from yesterday, make sure you guys know how to do it pretty well. Like I said, we're going to use that knowledge and we're going to start combining shapes. So let's take a look at our notes, questions 13 and 14. We're going to do what we call area of a composite figure. Now, composite figures are basically shapes combined with all the shapes. Let's take a look at this one. I'm going to do in red. My focus here is just on the parallelogram. That's my focus. And I know parallelogram, I'm looking at the two numbers that make the 90 degrees. So I'm just going to multiply them. Parallelograms, I treat them like a rectangle. So I know just for the parallelogram, I'm going to multiply 12 times 18. And I know 12 times 18, right? Use a calculator if you need to. 12 times 18 is 216. In this case, 216 feet squared. I'm just going to worry about the number. So 216. Again, I just saw the parallelogram on top. Now, if I look at the triangle at the bottom, I'm looking at this triangle. I know for triangles, to begin with, I have to multiply the two numbers that make the 90-degree symbol. So I have to go 18 times 11. And my result for triangles, I divide this by 2. Because remember that a triangle is half of a rectangle, right? 18 times 11 gives me the rectangle. Divided by 2, because that is a triangle, right? A triangle is half of a rectangle. So I'm going to say the triangle at the bottom is 99. The parallelogram on the top is 216. The triangle at the bottom is 99. Combined, this whole thing combined will be 315. Again, that's what we see as composite figure. It's a shape made out of combination of all the shapes. Let's take a look at number 14. That thing looks like a diamond, but I'm going to break it down into figures. The first thing I'm going to see, let me break it here. I see a trapezoid. And I know yesterday we saw trapezoids. I add the two bases. And when I say base, I'm going to say 10. And this bottom part is 19. So I'm going to add the bases. I remember for trapezoids, I have to go 29 because I added the bases. And I'm going to multiply times the height divided by 2. Now, to figure out the height, how much is the height? I know this thing on the right, this whole thing is 13. And I know part of it is 7. So I'm going to say this much is 7. So I'm going to say this other part is 6, right? 7 and 6 combined is 13. So the height of the trapezoid, when I look at the trapezoid, the height of the trapezoid is 6. So I'm just going to go 6 divided by 2. Remember for this type of shapes, for trapezoids, I add the bases. That's how I got the 29 times height divided by 2. Right, so 29 times 6 divided by 2. It tells me that trapezoid alone, just the trapezoid, is 87. Just the trapezoid. Now, let me focus on the triangle. So, matter of fact, for us to see it separate, let me do this in blue. I'm just going to focus on this triangle at the bottom. And I'm going to say here in the center, I know there's a 90-degree symbol. Now, for triangles, I know I multiply the two numbers that make the 90-degree symbol. So I'm just going to go 19 times 7 You guys see where I got the 19 from? And I know the length, I got the 7 from here. So I know 19 times 7 gives me a rectangle, but because it's a triangle, let me divide this by 2. So 19 times 7 divided by 2, my triangle alone is 66.5. So the trapezoid on the top is 87. The triangle is 66.5. Now both combined, so 87 plus 66.5 will give me 153.5. So for composite figures, you're going to break it down into shapes that you know. All right, we saw yesterday many shapes. So you're going to break it down to shapes that you know and then add them up. Some of your composite figures will have circles. You will have to find the area of a circle. We haven't seen circles yet at this point, but we will by the end of today. So that's why you're going to be able to use circles. All right, so that's composite figures. Like, so you guys are going to be doing about 5 of those in your homework. Now, question number 15 through 18, we have circles, but I see first of all, I ask you guys for the area. Right, 15 and 16, I want you guys to find out the area. Question 17, I want you to find the circumference. So there's a difference. There's a difference. So matter of fact, let me explain what's area and what's circumference. So let me talk about something about circles. Let me imagine I have a circle here. I have a circle and I made it out of strings, blues and red strings. I can cut them. I can cut them right to the middle, and then I can open them up. I can open them up like this. Or if I had a circle, I cut it right through the middle, it will open up like this. I'm gonna say the radius will be the height. For right now, let me just say the length, the long distance will be 2 pi r. For right now, let's just say that. I'll tell you guys later how I came out with the 2 pi r. Right, the distance around the whole circle for right now, let me call it 2 pi r. But the height is radius. Now that looks like a triangle. When I look at that shape, looks like a triangle. So I'm gonna say, all right, I know how to get the area of a triangle. The area of a triangle, I have to multiply the 2 measurements that make the 90 degrees and divide it by 2. Interesting part that I can go radius times radius. I know exponents. When I have the same base, I'm just gonna add the exponents. So I'm just gonna have 2 pi radius squared divided by 2. And again, the radius squared because I saw radius times radius. Interesting part is that I see the 2's. I know you guys can see the 2's that I'm pointing out. The 2's cancel out. So my area of a circle is going to be pi radius squared. Pi radius squared. Now, before I look at our notes, right, we know our formula for area. Let me take a look at what is circumference. Well, we start with circumferences. Imagine I have a circle and I have a radius. So I have the measurement radius. It is a measurement. So that means I can bend it. All right, if I had a string, I can make it go around the circle. The radius will not go around the entire circle. It would just go around a little part. It would just cover this much. That's the length of the radius. So that's actually a new measurement we're going to call radian. Right? It comes from radius. So if I had the radius as a string and I wrap it around the circle, it covers this much. Doesn't cover the whole circle. It just covers part of the circle. But then out of curiosity, I'm like, I wondered how many circles or how many radius would I need to cover the entire circle? Like how many radians would I need to cover the entire circle? And then I came in, I did it over here to show you guys. In yellow, we can see the first radius. In purple, we can see the second radius. Then you guys see there's a third, fourth, fifth, sixth, and there's a little bit. There's a little bit more. The last part is about 0.28. So I will say, all right, the circumference, the distance around the circle, let's just call it 6.28 radius, right? It takes me 6.28 radius to go around it. And I'm going to say about 6.28 radius. I know we've seen a number, decimal-wise, we've seen a number pi before. And pi is about 3.14. Interesting part is I know pi is 3.14, and I see a number 6.28. It's basically pi times 2. So the formula I'm going to use will be, for my circumference, is going to be 2 pi radius, or 2 pi radians. People call this radians. Is the measurement is used at how many radius go around the circle. It is 2 pi radians. So we're going to use this. We're going to use this. So let me come back to our notes. Let me come back here. Now I'm going to remember formulas. For the area of a circle, so 15 and 16, I'm even going to write it here. The area of a circle is going to be pi times radius squared. Radius squared means radius times radius, right? Radius twice. And radius is the distance from the center of the circle all the way out. So looking at number 15, let me remind myself of the formula. Area is equal to pi times radius squared. But I am told, use 3.14 for the value of pi. So I'm going to use a decimal for the value of pi. So when I'm doing this, I'm going to go 3.14. That's what I have for pi times 5 times 5. Notice I'm doing the radius twice. You guys can see where I got the radius. The radius is from the center all the way out. So I'm just going to grab my calculator. I'm going to go 3.14 times 5 times 5. And it gives me, my calculator gives me 78.5. Round your answer to the nearest 10. So your answer should only have 1 decimal place. That's exactly how I got it. So I'm fine. 1 decimal place, that's fine. That's all we do for areas of circle, pi times radius squared. But notice the radius is from the center out. Just crosses half of the circle. Question number 16, I don't have the radius. I'm going to say in this case, the radius is half of that. That 23.6, that's the diameter. We call that diameter because it crosses the whole circle. The radius is only half of the circle. So what we're going to do, we're going to cut that in half. Some people might be like, Leonzo, there's no half of 23.6. Yeah, use decimals. 23.6. So we're going to use a calculator if you need to. 23.6 divided by 2, it gives you that the radius is 11.8. I said, again, I just need the radius, which is half of the circle. So the way I'm going to find out what's the area, I know area is pi times radius squared. So I'm going to go 3.14. That's what I'm going to use for pi times 11.8 times 11.8. I use radius twice. So 3.14 times 11.8 times 11.8. My calculator, it gives me, to begin with, I typed it in, and it says 437.2136. Supposed to have only 1 decimal place. And I have more than 1. So I take a look at the second decimal place. It is too small. If it was big enough, when I say big is 5 or more, it will push the previous number up. But because it is too small, it doesn't. I'm just going to ignore this. I'm going to call this 437.2. One thing I'm going to say though, and let me emphasize, use 3.14 for the value of pi. I know some calculators have the key that says pi. Don't use it. Your number will be a little bit off. Will be a little more accurate. I'm going to give you that. 3.14 is a little less accurate, but I want us to be able to use any type of calculator. So for all of us to be consistent, I want us to use 3.14. And then question number 17 and 18, it says, find the circumference of each circle. Use 3.14 for the value of pi. Round your answer to the nearest 10th. Okay, so let's see. I remembered, I just showed you guys a few minutes ago, the circumference of the circle is 2 times pi times the radius. Some people, because if you guys Google it, you guys might even find that says diameter times pi. Yeah, if you combine 2 times the radius, that's the diameter. So some people call it diameter pi. I'm just going to call it 2 times pi times the radius. So in this case, the radius is 3. Let me write it under the circle. The radius is 3. I got the radius. That is what is given. So for me to find the circumference of this, I'm going to go 2 times 3.14 times 3. It's always 2 times pi times the radius. In this case, it gives me, my calculator says 18.84. But on the instructions I'm going to read, let me zoom out. It says, round your answer to the nearest 10th. All right, 10th sounds like the number 10, which is a 1 with 1 0. 1 0 means 1 decimal place. So my answer should only have 1 decimal place. My second decimal place is too small. 4 or less, it's small. So I'm going to ignore that. My answer will be 18.8. Technically, it's 18.8 square feet, but I'm not going to worry about the measurements. I'm more than anything focusing, do you know how to calculate the number? So when you guys type it in, just type in 18.8. Same idea for number 18. I need the radius. The diameter is 11.8. So the radius will have to be 5.9, which is the half of 11.8, right? I just went 11.8 divided by 2. So for my circumference, I know circumference, the distance around the circle is 2 times pi times the radius. So I'm going to go 2 times 3.14 times 5.9. So use a calculator if you need to. And excuse me, my calculator says 37.052. But I know I have to round it to the nearest 10th. So I do look at the 5, the second decimal number. It is big enough. So it's going to push the 0 to 37.1. Like I said, you might have the key that says pi on it. You might see it. Don't use it. Don't use it. Because instead of 37.5, you might even get something like different. Right? It might give you 37.1, but sometimes it might give you like 37.2. Like it goes a little bit off. Like I said, it is, if you use the key pi, that is more accurate, but I want us to all to be having the same answer. And I'm considering, what if you don't have a scientific calculator, or what if you're going to do it on paper by hand? I want us to all have the same answer. I want to stop at number 20. So I still have 2 more to go, but keep in mind, 15 and 16 word area. Remember the formulas: pi times radius squared. Circumference is 2 times pi times the radius. Make sure you read the instructions, because you're just going to get a circle. And if you don't read the instructions, you might get the area, or you might get the circumference, and you were probably needing the other one. Also, be careful on what you get. Some circles, I got the radius. Notice on 15 and 17, I got the radius. But sometimes you might get the diameter. I see question 16 and 18. So I might give you the radius. I might give you the diameter. I might ask you for the area, or I might ask you for the circumference. Make sure you understand what you're doing. All right, now the last 2 questions. Find the area of each sector. What we're going to be doing is we're going to find the area of part of a circle. We know how to find the area of a circle. Now, what if I only want part of it, not the entire circle? So I see here, I'm highlighting an area, and I'm just like, all right, what if I just wanted the area of that part? Not the entire circle, just part of the circle. What we're going to be doing, first of all, I'm going to find, I remember what's the area of a circle. I'm going to go area of a circle is pi times radius squared. I see the radius is 11. So if I wanted to get the circle, the area of the entire circle, I will go 3.14 times 11 times 11. That's if I wanted the area of the entire circle. So in fact, let me make this into a fraction. So I'm going to put it over 1. That's the area of the entire circle. Then when I only want part of it, I'm going to multiply this. So I'm going to multiply times a fraction. The area of the circle, I'm going to multiply by how much of the circle I have. I see that the section that I want is 225 degrees. I know the entire circle. We learned that last semester. I know the entire circle is 360. So I'm going to say I have 225 out of 360. So we get the area of the whole circle times how much of the circle we have. All right. So if I was to combine my two fractions, on the top of my fraction, I have 3.14 times 11 times 11 times 225. That's what I have on the top of my fractions. I'm going to combine it into just one. At the bottom, I just have 360, right? Because 1 times 360 is just 360. Now, let me type this in. I'm literally going to go the top part, 3.14 times 11 times 11 times 225 divided by 360. My calculator says 237.4625. But my instructions will say rounded to the nearest tenth. So my second decimal place is 6, is big enough. So my answer will be 237.5. Again, I just went 3.14 times 11 times 11 times 225 divided by 360. All right, let's take a look at question number 20. If I wanted to know the area of the whole circle, I will go 3.14 times 13 times 13. Pi radius squared. Guys, the radius is 13. Over 1, because I'm going to make this into a fraction. That's the area of the whole circle. Now I'm going to multiply this by how much of the circle I have. I have 300 over 360. If I was to combine this into one fraction, I have 3.14 times 13 times 13 times 300. At the bottom, I have 360. So 3.14 times 13 times 13 times 300 divided by 360. It gives me, my calculator says 442 point, there's a decimal, and then it says 2, 1, and a bunch of sixes. Okay, so I look at the second decimal place. It is too small. So I'm just going to ignore that. My answer is 442.2. Let me write this better. 442.2. My second decimal place was a 1, which is too small. Just ignore. Let me zoom out. Take a picture of it. If anything, the hard part will be composite figures. In one of your questions, you have only half of a circle. Right? On your composite figures, there's one question that has half of a circle. You know how to get the area of a circle. For the half of a circle, obviously get the area and then divide it by 2.